The notion of span is a very flexible and useful idea for expressing what solutions to differential equations look like. So for example, suppose we look back at hyperbolic cosine. So cosh, recall, is defined like this, and sinh is defined like this. Let's look at the span of cosh and sinh, and then we'll also look at the span of e to the x and e to the minus x. So let's notice. So from the definitions, it's clear that cosh x is in the span of R, and so is sinh, because both of them are linear combinations of e to the x and e to the negative x. For example, cosh x is 1/2 e to the x plus 1/2 e to the negative x. So these are linear combinations of e to the x and e to the negative x. Okay, that means then that since those guys are in the span of R, anything that can be built out of cosh and sinh, so if I have 3 cosh x minus 4 sinh x, then you can rewrite this in terms of, so this is going to be 3/2 e to the x plus 3/2 e to the negative x coming from the cosh term, minus 4/2 e to the x minus negative 4/2 e to the negative x coming from the sinh part. And so then we have minus 1/2 and so 3 minus 4 e to the x and minus e to the minus 1/2 e to the negative x. And so this is very definitely then an element of span R. So anything that you can build out of cosh and sinh, you can also build out of e to the x and e to the negative x. But then at the same time, we have that e to the x can be written as cosh x plus sinh x, and e to the negative x can be written as cosh x minus sinh x. And so that tells us that e to the x and e to the minus x are in the span of cosh and sinh. And so then what we have now is we have that the span of, so the all linear combinations of cosh and sinh, we saw at first, that's contained in the collection of all linear combinations of exponentials. And we also saw just now that any linear combination of exponentials, so anything from the span of R, is also contained in span of S, because it can be written as a linear combination of cosh and sinh. And so the conclusion for that is that these two sets must be the same, because each one is contained in the other. So the span of S is equal to the span of R. This means, for example, that if you're given a differential equation like y double prime minus y equals 0, then the solutions to this, the solution set can be written equally well as span S or as span R, because y equals c1 cosh x plus c2 sinh x is one way to express the general solution, but equally valid is y equals c1 e to the x plus c2 e to the negative x. Now, for a given function, the c1 that you have in this equation would be different from the c1 that you have in this equation, and so same for c2. But the general form of the solution can be expressed either way. Which way do you want to use? Well, there's advantages to both. The second one might be more familiar and simple, but for the first one, you're breaking it into something which is an even function and something which is an odd function. So there might be some advantages to using that as well.